Welcome to the Executive Protection and Secure Transportation Podcast. The podcast is provided by the International Security Driver Association. Every week, we share secure transportation and executive protection headlines, news, trends, and educational content for today's practitioners. Now, here's your host, Larry Snow.
Hello, and welcome to episode 205 of the Executive Protection and Secure Transportation Podcast. As we've said many times, the executive vehicle is the instrument used by a security driving and secure transportation profession to earn a living. Many of our association members are responsible for the selection and eventual purchase of the executive vehicles. In the next few years, all vehicles, including executive vehicles, will be changing at an exponential rate. The association will be researching those changes and their effect on secure transportation professionals. This episode will cover executive vehicle specifications, including H-point, vision line height, cargo room, and how these measurements affect the safety and security of the vehicle occupants. We'll also touch on another safety topic, Advanced Driver Assistance Systems, or ADAS for short, or ADAS. And so we'll start with visibility and seating height. In a secure transportation market experiencing the rapid increase in SUV use, visibility and seating height have never been a more scrutinized metric. The seating height is measured by measuring the distance from the driver's hip point, which automotive designers call the H-point, to the ground. The H-point number is a vital vehicle metric for the secure transportation community, especially when operating in a two-vehicle scenario. Simply put, the H-point is the theoretical location of an occupant's hip joint in a vehicle seat. The H-point could be considered the starting point when designing an interior because it influences many aspects such as roof height, seating height, collision performance, outward visibility, interior packaging, and even door apertures. It is determined by the SAE, International Engineering Organization's aptly named H-point machine, or HPM for short. The HPM is a plastic and steel human-shaped device that replicates the 50th percentile male. The first issues are engineering's definition of the 50th percentile male, which is defined as 69.1 inches tall, roughly 5 feet 10 inches, and weighing 172 pounds. We're not sure if the SAE assumes that females don't drive. The lower leg components of the HPM are adjustable, ranging from a male 10th to 95th percentile lengths. In its J1100 standard, the Society of Automotive Engineers, which manufactures and sells the HPM, defines dozens of interior measurements. The H-point number is used by the EPA to describe vehicle classes. The National Highway Traffic Safety Administration uses the number to position dummies for crash tests. So that's the HPM. The other component is the vision line height, or the VLH for short. The vision line height is the measurement from the car's floor to the top of the windshield. This region is where the driver will be looking when driving and encompasses the dashboard, wheel, and windshield. There is a difference between the headroom and the VLH. The vision line height measurements show approximately how high the seat of the car is. This is important to conceptualize, as having a position too high or too low can make it difficult to operate the vehicle. The vision line height can tell how much vision is cut off by the car's roof compared to the cabin's height. Comparing these two with headroom can tell you where your eye level might be and whether the roof will obstruct your vision. Security drivers and secure transportation professionals need to keep these numbers in mind. The best test method is driving the vehicle. If the same person is driving the exact vehicle every day, then determining the vision line height is not as problematic as it is for secure transportation providers who may have multiple people driving the vehicle. The vision line height is important in determining dead zones, areas in front or behind the vehicle obscured from vision. The most important result of the vision line height is something that we have talked and written about in the past, which is the driver's perception of speed. In his book, Traffic, by Tom Vanderbilt, he discusses why drivers unknowingly drive faster than they think. The information was taken from 2 studies. The first study was on the perception of speed. The research found that the quote-unquote average driver is 15% off. They drive 15% faster than they think they are, and the higher you sit in the vehicle, the worse it is. This issue also has implications in training. As a security driver trainer, you need to be cautious of the speed in SUVs and monitor them carefully. So if you think you're driving at 40 miles an hour or 64.5 kilometers per hour, you are more than likely driving 46 miles per hour or 74 kilometers an hour. If you're driving at 60 miles per hour or 96.6 kilometers per hour, you are probably going 69 miles per hour or 111 kilometers per hour. To carry this one step further, an increase in speed of 15% would represent an increase of 30% in the energy the driver will need to manage in an emergency maneuver and an increase of 30% in the distance required to stop. The second study was conducted to assess drivers' chosen speeds when operating a simulated vehicle, doing so while viewing the road from a low eye height, which would be the case if you were driving a sedan as the lead vehicle in a 2-vehicle scenario. Participants were instructed to drive without reference to a speedometer at highway speed at which they felt comfortable and safe. Drivers seated at a high eye height, which would be in an SUV in a 2-vehicle scenario, aka the follow vehicle, drove faster than when they were sitting at low eye height, a sedan, for example, as the lead vehicle. There is little a driver can do about the vision line height except be aware of its effect on driving and motorcades. Raising and lowering the driver's seat changes the driver's perception of speed. The driver of the follow vehicle needs to be cautious of their speed. Lots of consideration needs to be given to who is driving the vehicle as well. Putting a driver with little or no experience driving the SUV as the follow vehicle in a motorcade is problematic. You would be neglectful if you do not talk about the vision line height in protective driver training. If the instructor judges your speed while sitting in the passenger seat, their perception of speed could be as much as 15% off. While conducting training, a radar gun or an onboard computer must be used to measure speed. And we'll have a link in the show notes to episode 181, where we talk a little bit more about the perception of speed. Another safety aspect in your vehicle is cargo room. How much luggage a vehicle can carry has always been a major concern in every survey we have conducted concerning executive vehicles. We have found that just because the SUV makes the cargo area look big, the cargo volume may not be what you expect. The reason is due to the complex shapes, the door opening contours. It doesn't really tell you exactly what can fit in one vehicle versus another. From a safety concern, there is a metric that is important. It's called the static stability factor, or SSF for short. The SSF is how the National Highway Traffic Safety Administration determines a vehicle's rollover probability. It is the vehicle's at-rest calculation of its rollover resistance. The number is based on the vehicle's geometric properties. The static stability factor is a measure of how top-heavy a vehicle is. The more cargo you put in the vehicle that is located above the vehicle's center of gravity, the more prone the vehicle is to tipping over. The lower the static stability factor number, the more likely the vehicle will roll over in a single vehicle crash. A higher static stability factor value equates to a more stable, less top-heavy vehicle. The National Highway Traffic Safety Administration rates the SSF of a vehicle by using a star system. For example, 5 stars is less than 10% chance of a rollover. 4 stars, 10 to 20% chance of rollover. 3 stars, 20 to 30% chance of a rollover. 2 stars, 30 to 40% chance of a rollover. And 1 star, greater than 40% chance of a rollover. We'll have a link to the NHTSA website in the show notes where you can find more info about SSF and how NHTSA computes the SSF number. So you might be asking yourself, well, what are the SSF star ratings for some of the more prevalent executive vehicles, probably one that you might be driving? The Mercedes S-Series is 5 stars, or a less than 10% chance of a rollover. The Lincoln Navigator is 4 stars. The Chevy Suburban is 3 stars. A Mercedes Sprinter van, which is very popular these days, comes in with a 1 star or a greater than 40% chance of a rollover. All of these static stability factor safety ratings are measured when the vehicle is unloaded. If the luggage is loaded into any of these vehicles above the center of gravity, the rollover probability increases. So, as we do here on the podcast and in the association, we put these numbers into a scenario. In this case, a 2-car scenario. Let's say the lead car is a Mercedes S-Class and the follow vehicle is a Suburban. When driving through a corner onto an off-ramp performing an emergency maneuver, the Suburban has more of a propensity to roll over than the Mercedes. Is this a problem? Well, as long as the vehicle is in the hands of a professional, no. But if the vehicles are driven by those with no training or experience, yes. Another item to be aware of when it comes to vehicle safety is the vehicle safety rating. The job of a security driver, obviously, is to supply safe and secure transportation. Hence, the vehicle safety rating is of importance. The best source of information concerning vehicle safety is the National Highway Traffic Safety Administration and the Insurance Institute for Highway Safety. These two organizations perform crash tests on cars in the United States. The ratings those agencies produce are found on the vehicle's window stickers and are the standard for vehicle safety ratings. And we'll have a link to NHTSA and the IIHS websites where you can go check out the ratings on some vehicles. Another safety feature that has risen dramatically over the last 10 years, 15 years, is the Advanced Driver Assistance Systems, or ADAS, or ADAS. Most of all executive vehicles are equipped with a full array of what this is active safety technology. Here are a few of the more prominent ADAS features and what they do. Forward collision warning gives visual, tactile, or audible warnings that alert the driver to the possibility of collision with an obstacle in front. Automatic emergency braking automatically applies brakes to prevent or reduce impact force in a collision with an obstacle in front. Adaptive cruise control keeps a constant distance between you and the car ahead, automatically maintaining a preset following distance. Blind spot warning provides a warning that something is in the vehicle's blind spot. Lane departure warning gives warnings intended to alert the driver that the vehicle is crossing lane lines. And lane keeping assist provides automatic corrective steering or braking to try and keep the vehicle in its lane of travel. So these are all pretty good things, right? Probably in some cases necessary, you might say. So what's the issue? Well, the issue is every manufacturer has a different name for each of these ADAS features. Of more importance is that not all ADAS systems are created equal. They have other methods of alerting the driver of a problem. One system may use a light to warn the driver, another may use a sound system for the same problem. If the exact vehicle is driven, then it's just a learning curve. But it will be a problem in a secure transportation provider scenario where different drivers are driving the same vehicle and are not familiar with the alert systems. This problem is easily solved, of course, when getting into an unfamiliar vehicle The professional security driver needs to get familiar with all the ADAS features and their alert notification systems. And to gain some understanding of the ADAS features, we suggest looking at the association's YouTube channel playlist devoted specifically to ADAS. And we'll have a link to that in the show notes. Oh, and if you're not yet subscribed, you may want to as we update our playlists frequently. And the last safety issue we'll talk about in this episode is one that is dominating vehicle advertising, and that is autonomous vehicle levels. Some have touted driverless vehicles on various social media outlets, news reports, and vehicle ads. And there's a TV ad that you may have viewed. It shows a group of people driving while clapping their hands to the music. Basically, driving for a considerable length of time in traffic with their hands off the steering wheel, which is completely irresponsible, but not illegal. As a security driver or provider of secure transportation, we are confident that we don't need to remind you to keep your hands on the steering wheel. That is not to say that basic autonomous vehicles are here to stay and your client or principal is watching the same TV ad. As a security driver or provider of secure transportation, your client or principal expects you to stay current and know the ever-increasing technologies available in executive vehicles. Various levels of autonomous vehicles and their effect on the driving task are some of those pieces of knowledge we recommend you have. And for additional information, we suggest listening to episode 172 of this podcast, titled Autonomous Vehicle Levels and Security Driving. That'll do it for me this week. Thanks so much for listening. I really appreciate it. The links to all news stories mentioned in this episode are available at securitydriver.com. We welcome any comments, feedback on the podcast, or topics. If you haven't done so already, please subscribe to this podcast so you won't miss another episode. And if you've been listening for a while and you're really enjoying it, we would love a review. A review helps us get the word out about the podcast, and we also learn from your feedback and make the show better. If you have an interest in going much deeper into these type of topics, I invite you to check out the International Security Driver Association's website and consider joining the only organization dedicated to supporting the advancement of professional security drivers and other protection practitioners with data-driven research and other professional development tools. For more information on all of the member benefits, head on over to isdacenter.org.
Thank you for listening to this episode of the Executive Protection and Secure Transportation Podcast, provided by the International Security Driver Association. If you're enjoying the show, please feel free to rate, subscribe, and leave a review wherever you listen to your podcasts. We really appreciate that effort, and we'll catch you in the next episode.